Okay, the first is physical layer. As you can see here, this will go in this order: physical layer, data link layer, network layer, transport layer, application layer. Okay, let's start with the physical layer. And as you know, physical layer is the lowest layer in the TCP/IP model, isn't it? This is the last layer. And the PDU, that is protocol data unit of this layer, is bits. You have to remember all this. So these are all the basics things that we are going to discuss here. So all these are important to study further topics in the syllabus. Okay, please do remember. So this physical layer is responsible for many functions like interfaces and medium, representation of bits, data rate, synchronization of bit, line configuration, physical topology, and transmission mode. So these are the functions that will be performed by the physical layer. See, all this detail is not give, you need not to study in detail about all this function. Just remember, these are the functions that are implemented at the physical layer. Okay, and important thing that you have to remember is this part. Okay, see, as I said, at the physical layer, one second. At the physical layer, the data is represented in the form of bits. That means protocol data unit of physical layer is bits. Okay. So that the physical layer receives the data from the data link layer. You have to remember this. Physical layer. So let's consider the previous slide. See here. One second. Huh. See, the data is created at the source node. Okay, so that is at the application layer. Application layer pass the data to transport, transport to network, network to data link to physical layer. Okay, so this again from the physical layer it will transfer to physical layer at the destination host. Okay, so now we'll start. Since we have started from this layer, the data will be received from the data link. This you have to remember. Okay, yeah. See, the physical layer receives the data from the data link layer, right? And this data we call it as bits, right? And this, excuse me, whatever the bits are received, I mean created at the physical layer, is transferred to the transmission medium. Okay, that is the duty of the physical layer. This bits will be transmitted over the transmission medium. Okay, and this again delivered to the physical layer of the destination host. Okay, so you have to remember this. See, if the transmission medium can be cable connection, that is twisted pair cable, or it can be optical fiber, or it can be wireless, that is radio waves. So whatever the bits are created at the physical layer, that will be transmitted to transmission medium. Okay, so this bits will be converted into signals. Okay, if my transmission medium is cable, then it will be converted into electrical signals. If my transmission medium is optical fiber, then the bits are converted into optical signals. If my transmission medium is wireless, then this bits will be converted into radio signals. So in this way, the functions of physical layer will be implemented, or you can say this is how the physical layer works. Okay, this is all about the physical layer. So comes next layer in the TCP/IP model is data link layer. Okay, so data link layer is data link layer receives the data from the upper layer. Which is the upper layer of data link layer? That is network layer. Okay, data link layer receives the data from network layer. Okay, that is you have to remember. Now, and this data link layer is responsible for sending the packets to the adjacent nodes. So in the network, one second, let me use this diagram. No, that diagram is not here. Okay, this data link layer is responsible for, see here, if I consider this is a network, okay, and I want to send data from, consider this as source and this as destination, and this as intermediate node, okay, and there exists link between all these devices, okay, this is source, this is destination, and this is intermediate node. So if I want to send the data from source to destination, obviously it will take this path, right? So now this data link layer is responsible for sending group of packets, see, that is data, group of packets to the adjacent nodes, okay, without any error. So the data will be sent from source to intermediate node and from here to here. So this data link layer is responsible for sending group of packets to the adjacent node, and we call this as end-to-end delivery. Please, you have to remember this. Data link layer is responsible for sending group of packets to the adjacent node in the network, and we call this as end node to node delivery. Okay, and while sending, it has to take care there should not be any errors as well. Okay, I hope this is clear to everyone. And
Ma'am, it
we
is end to end or node to node, ma'am?
node to node, node to node, end to end is this one. Okay, node to node is this one. That is sending data from source to the adjacent node that is there in the network. So node to node. I'll just write it here. Node to node. Yeah, data link layer follows node to node delivery. Okay, and there are a few functions which are implemented at this layer, that is framing, physical addressing, flow control, error control, and access control. So these are the functions that are performed by the data link layer when there is a communication between the parties. Okay, we'll see now what is framing. So the first one, that is, what is framing? So see, as you can see in this diagram, the data received from the network layer, as I said, right? Data received from the network layer, and here this is the data that is received from the network layer. Okay, for this additional data is added, that is header and Taylor here. Okay, these two additional information is added to the data that is received from the network layer, and this together we call it as framing. Adding additional bits of data to the data that is received from the network layer is called as framing. Okay, so that addition bits are nothing but adding header and Taylor here. Okay, so here, so altogether I've considered a diagram for this, where for the data, header and trailer are added. So these are nothing but certain bits or additional bits that is added to the data. So header includes start of the frame. See, and one more thing, framing, right? The PDU, this is very important. The protocol data unit used at data link layer is called as frames, right? With respect to physical layer, it is bits, right? So with respect to what data link layer, it is frame. So why? Because the data received from the network layer is added with additional bits, that is header and trailer, and this we call it as framing. So this altogether you call it as a frame. Okay. So certain bits at the header says it is the start of the frame, and it also specifies the addressing types that is used. Addressing types we are going to discuss in a minute later. Okay, and also it includes the quality control. Okay, and other set of additional bits are represents trailer, which checks error in the message, that is error detection, and few other bits represents frame stop. I mean where this frame stops. Okay, so these are the bits that are used to form the framing, header and trailer. Okay, so header will specify addressing and addressing type and the quality control. Trailer bit represents helps to detect the error in the message. So this all together we call it as framing, and this is one of the function which is implemented at the data link layer, and data link layer follows node to node delivery. Please remember, node to node delivery. Okay, and next function here with respect to data link layer is physical addressing. This is the second function that is implemented at uh, sorry, physical addressing, which says uh, the source address and the destination address in the header part. See, I said in this slide, it specifies the addressing types, right? So at the header, it includes just the marker, header. It says addressing type, right? So here addressing includes source and destination address. So to which, I mean, the data is received from which host and data has to be delivered to which host. That address will be presented in the physical addressing part. Okay, and next is flow control. The third function implemented at data link layer is flow control. See, flow control is nothing but the mechanism which is used to control or monitor the flow of information inside the network without any congestion. See, flow control is nothing but a method, or it can be a mechanism which is used to control or monitor, or altogether you can say which governs the flow of information inside the network without any condition. See, we all might have experienced this. See, during New Year, right? December 31st after 12 o'clock. Okay, if you try to send message or you make a call to your friends or anyone, you may find the traffic there. That means you may get the line seems to be busy, or you may have dropping of calls. All such things happens, right? Why is that so? Because at that point of time, the number of users using the network will be more. The count of users who are using the network will be more, right? What does it mean? When number of users are more who are accessing the network, then obviously there is a congestion, which is nothing but traffic in the network. Okay, so that is controlled at this data link layer, that we call it as flow control. If there is a congestion, it has to be taken care. That is done by this flow control function. I hope I'm clear now. And next function implemented is error control. Error control. See, again, this is certain mechanisms are followed to control or to minimize the error that may occur in the data. So that is error control. Access control, again, this is takes care like who can access the data, and based on certain conditions that will be taken, that is called as access control. I mean, who and all can access the data, that is taken care by this function, access control. Okay, these are the different functions which are implemented at the data link layer. I'll just summarize. Data link layer is responsible to transfer group of packets to the adjacent node. Okay, and this we call it as node to node delivery, or you can say hop to hop delivery. Okay, and the functions that are implemented at the data link layer are framing, physical addressing, flow control, error control, and access control. Okay, so framing is what the data is received from the network layer. I mean, data for the data link layer, the data will be received from the network layer. I mean, data passed to the data link layer from the network layer. Okay, for this data, header and trailer will be added. Okay, these header and trailer are nothing but additional bits added to the data. Okay, header will help you to find out the addressing type and the quality control, and the trailer will helps you to find out error detection in the data. Okay, adding header and trailer to the data is called as framing. Okay, and the PDU, that is protocol data unit at the data link layer, is frames. Okay, okay. After that, the second function implemented is physical addressing. The physical addressing says the address of source and address of destination, that will be specified here. Flow control. See, flow control is that when there is a congestion in the network, this has to, certain mechanism has to follow, so that the packets has to be sent over the network without any congestion. That is flow control. And the error control, few mechanisms are followed to reduce the errors in the packet. Okay, and the access controllers, the who and all have the access to the data, that will be controlled by this access control function. So altogether, these functions are implemented at the data link order. Okay, so next we'll move to the network layer. See, and about this network layer, this layer is responsible for routing the packets from one network to another network. Do you remember? Network layer is responsible for routing, okay, the packets from one network to another network. And we also call it as source to destination delivery. Network layer is responsible for routing the packets from one network to another network, that is source to destination delivery. You have to remember this. Okay, and the functions that are implemented at this layer are logical addressing, and the second one is routing. Okay, so let's consider this example. Here, this is one user and this is another user. Okay, and both of them are connected to different layers, different networks. This is network 1 and this is network 2. Okay, so now if I want to send a set of data to this destination host, and you can see in this diagram, this network is connected with this with the help of intermediate nodes here, isn't it? Here this router is intermediate, this is also intermediate, and this network 1 is connected to network 2 with the help of connecting devices, that is link, which is nothing but a switch here. Okay, with the help of switch, I have connected my network with this router with another switch, in turn to another router, in turn to switch, and which is connected to another network. Okay, so now what does this network layer does? It takes the responsible, sorry, this layer is responsible for routing the packets. See, where is the marker? Routing the packets from one network to another network. Okay, routing the packets from one network to another network, and we call this as source to destination delivery. See here, this is only with respect to one packet. As in the first class only, I told you, if I want to communicate with my friend or with you, I generate data, right? And this data will be divided into chunks of packets. You all remember this, right? Chunks of packets. You please do remember if you have forgotten. The data will be divided into chunks of packets. Okay, this network layer is responsible for delivery of one packet from source to destination. Now imagine I have generated 1 MB of data. Okay, I have generated 1 MB of data. Then this data will be divided into number of packets, not one packet, number of packets, right? Out of which one packet is delivered from source to destination. This we call it as source to destination delivery, and this is the responsible of this network layer. Okay, so the functions that are implemented at this layer is logical addressing, and the second one is routing. We'll see one by one now. Logical addressing. See, this is addressing a particular system in a logical way. Okay, addressing a particular system in a logical way, that we call it as logical addressing. For example, see, I connected to Hathway network here. The router Wi-Fi I'm using, I'm connected to Hathway network. Okay, so my IP address may be like 192 point. You might have seen this in your system, like 192.168 point like 1001. So this IP, this we call it as logical addressing. That means it helps you to find out your system is connected to which network. Okay, so do understand, logical addressing is addressing done to a system in a logical way. Example is IP addressing, that is internet protocol addressing. You might have seen this IP address in your laptop, right? So this helps you to find out your system is connected to which network. See, I connected to Hathway network, so my what IP address is this one. If I connected to Airtel network, then the logical addressing for my system will be different because I'm connected to a different network now, right? So this we call it as logical addressing. Okay. Next function is routing. Routing is what? Routing the packets in the right direction to reach the correct destination. Let's consider this example. So routing helps you to deliver the data to the right destination. See, for consider this is, I have taken a small diagram in the network where there exists two paths. See, I have to send the data from this node to this node. Okay, there exists two paths. One is this way, another one is this way. So it is the duty of the network layer to select the proper path so the data should be delivered, the packet should be delivered to the correct destination. Okay, it should not pass the wrong direction here. It has to select the proper path to deliver the data. Okay, these two are the functions of network layer. Is this clear? Is this clear with respect to network layer? Any doubts? Any doubts, students?
No, ma'am.
Okay, I'll move to the next thing then. So here this is to represent for the network layer, data will be received from the transport layer. Okay, then okay, these are the few things you need to know. Network layer is responsible for host to host communication, or you can say source to destination delivery, and it also routes the packet through possible routes. And this layer, this network layer uses protocol, that is internet protocol, and this internet protocol defines the format of packet. How to represent the packet that is given here, and the PDU, protocol data unit, for network layer is datagram. Okay, and then it also defines what should be the format and the structure of addresses. We spoke about a logical address, right? And so this IP, that is Internet Protocol, also defines format and the structure of addresses. Okay, and this I already explained. IP is used for routing a packet from source to destination. Okay, next, this IP is a connectionless protocol, internet protocol. So do remember, at the network layer, internet protocol is used, which helps to route the data from source to route the packet from source to destination. And this IP, internet protocol, is a connectionless protocol which doesn't provide flow control, as we discussed flow control in the previous layer, and it will not provide error control, and it also not provide congestion control services. Okay, if you need to have all the services, then we have to rely on the upper layer, that is transport layer protocols. Fine. So see, to explain what is connectionless protocol, let me consider this. You might be wondering what is connectionless protocol, right? See, consider this example where this is the source and this is the destination. One second. Huh. This is source and this is the destination. As I said, the data will be divided as different chunks of packets, right? See, now there are 4 packets. My data is divided into 4 packets, and I want to deliver the data from this end to this end. Okay, there exist multiple paths. See here, one path is this one, another path is this one. Okay, so set of packets, say 3 and 4 follows this path, whereas 1 and 2 follows this path, right? See, it means there is no one proper connection followed to deliver the data. That we call it as connectionless protocol. That means the flow of packet will not be dependent on one particular path. That we call it as connectionless protocol. This is all about network layer protocol, and there are few other protocols followed in this network layer, that is ICMP, that is Internet Control Message Protocol. Okay, this protocol is used to help report some problems when there is routing a packet. See, when the packet has to be delivered, right, from source to destination, if it finds if any problem, then this protocol is used to find out that problem. Next protocol is IGMP, that is Internet Group Management Protocol. This helps IP in multitasking. And one more, that is DHCP, Dynamic Host Configuration Protocol. This helps Internet Protocol to get the network layer address for a host. Okay, see, that means it helps to get the network layer address for a host, DHCP. And ARP, that is Address Resolution Protocol, that helps IP to find the link layer address of a host or a router when it network layer address is given. See, as of now, you just remember these protocols are used in network layer because as course progresses, we are going to study this network layer protocol in detail. Okay, so these are the different protocols used in the network layer along with internet protocol here. Okay, and next layer is transport layer protocol. See, this transport layer, uh, is, I mean, next to transport layer, there is application protocol, right? Below, below to this layer, we have network layer, right? Transport layer, it is responsible for process to process delivery of the entire message. So we'll see that by considering an example, okay? But you have to remember it is a process to process delivery of an entire message. Okay, next, what is a process? It is an application program that is running on a host. See, I'm using WhatsApp. Okay, I'm just sending a message to my friend. Okay, so this whole message should be delivered to my friend WhatsApp number. Okay, this we call it as a process or application program. Okay, we'll see what are the functions that are implemented at transport layer protocol. Sorry, transport layer. Functions are service point addressing. One second. Next, segmentation and reassembly. Third one is connection control. Fourth one is flow control. And the fifth one is error control. These are the functions implemented at the transport layer. Okay. So do remember, transport layer is responsible for process to process delivery of the entire message. Let's consider this diagram. See, transport layer, I said process, right? Huh. This is the process or the application, okay, that is running at my system, and I just send a message to my friend who is located in another city. Okay, so we are connected over an internet, right? So this process, and let's say I'm just sending her a message, sending how you doing. Okay, that data will be divided into number of packets, right? So that whole set of packets should be delivered to my friend. So that we call it as a process to process delivery. Do remember, in network layer what happens? Source to destination delivery happens with respect to one packet. Okay, whereas in transport layer, entire message will be delivered from source to destination. Message is what? Chunks of packets, right? This whole set of, I mean, entire message has to be delivered from source to destination. That happens in transport layer. And this is also called as source to destination delivery with respect to entire message. Whereas network layer, source to destination delivery with respect to a packet. I hope the difference is clear to you.